Hi everyone, welcome back. This is part 3 of control structures in Java. My name is Dr. Hang Ding and I am an associate professor at Indiana University South Bend. In this video, I will cover section 7 in my presentation about control structures in Java. So it's about formulating algorithms, nested control iteration. So first, let's go over the concept of nested control iteration or nested loop. Recall that the loop body of an iteration statement can be any valid Java statement. So it can be another iteration statement, in which case they form nested loops. As a simple example, consider the following Java code fragment which has nested loops. The outer loop iterates through characters from A to E using variable outer as the control variable. For each iteration of the outer loop, its body first print out the value of the variable outer followed by a colon. Then it has an inner loop that iterates from 9 down to 0 using variable inner, which is an integer, as the control variable. This inner loop simply prints out the 9 decimal digits in the decreasing order. And after the inner loop, the loop body of the outer loop prints out an asterisk or star and moves the cursors to the null line and then increases variable outer by 1. So this is what the result of this code. So here you can see that it loops through A, B, C, D, E, and for each loop it loops through 9 down to 0. When you write nested loops, it's important to have proper indentations so that the structure of the nested loops can be recognized easily. When it comes to writing a program that would require nested loops, a lot of students feel overwhelmed and confused because either they didn't write an algorithm before coding or they try to write an algorithm with nested loops all at once, and that can be overwhelming. The best strategy to design algorithms, especially those with nested loops, is to use the top-down approach. The common principles of the top-down approach is that you start with an algorithm outline which can have abstract and big steps. Then you keep refining each step until it's straightforward to convert it to a programming language. But during the refinement process, an intermediate step can be a simple loop whose loop body contains abstract or intermediate steps. A refined step may become an inner loop. That's how the nested loops are formed eventually. The rule of thumb is that in each refinement, write only simple loops, not nested ones. That means that you can refine a step into a single loop but not into nested loops right away. Also, you should refine outer loop before refining its loop body because the details of the loop body may depend on the control variable of the outer loop. I'll show you examples of how this strategy is applied. Let's consider an example of formulating an algorithm with nested loops. The problem in this example is to write a Java program to display a triangle with 11 lines of stars or asterisks like this. Each line has 21 characters, including only spaces and the stars. We can number the lines from 0 to 10, where line number n has n plus 1 stars in the middle of the line. So both sides of the stars are space characters. To develop an algorithm for the triangle problem with the top-down approach, we first write an algorithm outline for this problem. The outline consists of a simple loop that goes through each line, and for each line we will have to do 3 steps: display the spaces before the stars, display the star, and then display the spaces after the star. That's the pattern we know at this point. No more details in the outline. Both the loop, which is marked as step 1 in the outline, and its body need to be refined. But we should refine the loop first. To define the loop, we need to figure out the details of how it iterates through the line. To figure that out, we know that there are 11 lines numbered from 0 to 10, so we will use a control variable n to go through the lines. So we first set n equal to 0, then the loop iterates while n is less than or equal to 10. In its body, we still need to have the original loop body in the outline, but we need to add a few more detailed steps to move through the lines. Those are to move to a new line and increase the variable n by 1. So the outer loop is already detailed enough, and we don't have to refine it further. At this point, it's a single loop. However, its body still has 3 steps from A to C that need to be refined. To refine step A in the outline, we need to figure out how many spaces before the stars in line number n, where n is the control variable of the outer loop. We know that each line has 21 characters, and line number n has 2n plus 1 stars. So the total spaces in line number n is 21 minus 2n plus 1 in parentheses, which equals 20 minus 2n. Since the number of spaces in line, the spaces before the stars and the number of spaces after the stars are equal, each of them equals 20 minus 2n altogether divided by 2, which is 10 minus n. So there are 10 minus n spaces before and 10 minus n spaces after the stars in line number n. Hence, to display the spaces before the stars in line n, we just set up a counter-controlled loop that prints 10 minus n spaces 1 by 1. So we define this step A into these steps. First, set variable count to 1. Then while count is less than or equal to 10 minus n, print 1 space and increase count by 1. To define step B in the body of the outer loop, which is to display the stars, we just need another counter-controlled loop to print 2n plus 1 stars 1 by 1. So we define this step B into this step set count equal to 1, while count is less than or equal to 2n plus 1, print 1 star and increase count by 1. Step C in the body of the outer loop, which is to display the spaces after the stars, is refined the same as the step A, because both display 10 minus n spaces. As you can see, the details of these steps in the loop body of the outer loop depend on the control variable n of the outer loop. That's why we need to refine the outer loop before refining its body. So here is the complete algorithm for the triangle problem. It has nested loops. In particular, it has 3 loops inside the outer loop. But during the process of developing this algorithm, we wrote only simple loops at a time. Now we can translate the pseudocode algorithm for the triangle problem into a Java program named triangle.java. So this program has class triangle. Here I copied the complete pseudocode algorithm and placed them above the class triangle declaration for quick reference. One tip is to copy the algorithm outline and place them inside the inside the body of the main method of the program, and then comment them out. Right. Then we will fill out the details of each step in the algorithm outline with the Java code converted from the refined steps of each of these steps in the outline. Now we start with translating the outer loop. So we start with set n equal to 0, and here we have to declare n as an integer variable, and then y n less than or equal to 10. So this one comes in the loop. And so inside the loop here, we also have this step, and then we also have to move to a new line. That is, we print out a new line character. Okay, so that the cursor will move to the new line for the next display method. Okay, then we increase n by 1, so n plus plus. Now we translate each of this step in the loop body of the outer loop. The step 1 display the spaces before the star, so that corresponds to this part of the pseudocode. So here we have to set count equal to 1. Okay, and here we also have to declare variable count as integer. Alright, so then y count is less than or equal to 10 minus n. Okay, so then we print out one space, so system.out.print, then just put one space between the double quotes, and then increase counts by 1. Alright, so then the second one is to display the star, which is similar to this code. So I copy and then paste them here. Okay, just make one space here, and here we need to modify count is less than 2 times n plus 1, and here we print out 1 star. Alright, so the last one here is similar to the first one, so it's the same. Alright, so that's it. So now let's run this program. Okay. All right, so it works. That's it. So that's the end of this video. Thank you for watching. I hope you find it helpful, especially for formulating algorithms with nested loop. I'll see you again in the next video.